Subgroup, we start subgroup, and today we will discuss about some properties or theorems on subgroups. And we have already studied the definition of subgroups. And subgroup means a non-empty subset H of a group G is called subgroup of G if H is stable for the composition of G and H is itself a group. Means H satisfies all the conditions which satisfied group G. Means closure property, associative law, identity elements exist and every element has its inverse. So this is the means definition of subgroup. Now we come on definition like complex. A non-empty subset. A non-empty subset H of a group G. A non-empty subset H of a group G is called complex. Whether it is a group, it is a subgroup or a non-empty subset. A non-empty subset of a group G is called complex, whether it is a subgroup or maybe subgroup or may not be. So it is, suppose H and K, H and K are subgroup of G or complex group G, then HK. How we denote HK? HK is denoted by HK. So for all H belongs to H, K belongs to K. So H and K are subset of group G or subgroup G. Then HK is denoted by HK. H belongs to H, K belongs to H. And H inverse, what is H inverse? H inverse. For all H belongs to H. Here it is understood. Here the composition is multiplication. Multiplication composition is given. Then this is maybe other composition is given. Then we will use that composition. H star K means H star K here H inverse. If multiplication composition is addition, then this becomes minus H. Or this is H plus K. Like this. Suppose, for example, if H is equal to, suppose minus 1, 3, K is equal to 2, 4, are complex, Z plus, are complex Z plus, then what is HK? And HK, what is HK? Here composition is multiplication, then but here it is given composition is addition. So HK means H plus K, like this. So minus 1 is minus 1 plus 2, minus 1 plus 4, 3 plus 2, 3 plus 4. HK is 1, 3, 5, 7. This is HK because composition is addition. What is H inverse? H inverse is equal to, composition is associative, so inverse is, if A belongs to H, then inverse of A is minus A. Means minus 1 minus 3. It means 1 minus 3. This is H inverse. What is K inverse? K inverse is minus 2 because here composition is plus addition. Suppose if composition is multiplication, suppose h is equal to minus 1 1, k equal to iota. These are complex of g 1 minus 1 iota minus iota dot. Here composition is multiplication. So what is hk? Now hk h into k. Every element of h multiplied by every element of k means minus 1 into iota minus 1 into iota 1 into iota means minus iota. This is hk. Now h inverse. What is h inverse? What is multiplicative? If a belongs to h, then multiplicative inverse of a is 1 upon a. Means 1 upon minus 1, 1 upon 1. It means minus 1 h inverse. What is k inverse? 1 upon I means minus I. This is k inverse. So is addition, composition is multiplication, then we will find hk and h inverse k inverse like this. Addition, then h plus k or minus h like that. So these are some property of complex. If h and k are, we can see here if h and k are complex of g, if h and k are complex of g, then we can say first hkh is equal to hkh in hh inverse equal to h or h inverse equal to h if h and k are complex of g. Here hk equal to kh. It doesn't mean hk kh means does not mean hk is equal to kh. It doesn't mean hk is equal to kh. If hk is equal to kh, it doesn't mean hk is equal to kh. Because it means, what is the means of this one? It means every element of hk is in kh and every element of kh is in hk. What is the meaning of this one? Means hk subset of kh and kh subset equal to hk. So meaning this hk is equal to kh means this one, not like this, not this hk is equal to kh. This doesn't arise here. Means hk is subset of kh and kh is subset of hk. So this is some basic property of complex. Now we solve some theorems of subgroups. First theorem is, these theorems are very important. So these are very important theorems of subgroup. Necessary and sufficient conditions. So the necessary and sufficient condition sufficient condition of subset H is a subgroup of G is A belongs to H, B belongs to H, A B inverse H. Here, if any composition is not given any composition, it means the composition is multiplication. Okay, so A belongs to H, B belongs to H, A B inverse belongs to H. If H is a subgroup of G, then we will show that A belongs to H, B belongs to H, A B inverse belongs to H. And if we suppose that A belongs to H, B belongs to H, A B inverse belongs to H, then we have to prove that it is a subgroup of G. What is subgroup? Subgroup means it satisfies all conditions of group. Means H is stable for the composition of G, means H is closed, or H satisfies all conditions of a group, means closure property, then associative, multiplication is always associative, and inverse and identity element exist. Like this. We have to show that. Then first we suppose sufficient necessary condition. So now suppose H is a H is a subgroup of G. H is a subgroup of G. It means H is satisfying all conditions of a group. Means inverse exists, identity exists, closure property exists, associative law exists. It means suppose A belongs to H, B belongs to H, or suppose B belongs to H, means it satisfies all property of group. Means if B belongs to H, then its inverse is also in H, means B inverse belongs to H. So A inverse belongs to H. So we can say suppose A inverse belongs to H, B belongs to H, means A belongs to H and B inverse belongs to H. A belongs to H, B belongs to H, means A belongs to H and B inverse belongs to H. And it is a subgroup when it is satisfying always closure property. It means what is closure property? A belongs to H, B belongs to H, A B belongs to H. Closure property means A belongs to H, B inverse belongs to H. Means A B inverse. A belongs to H, B belongs to H, A B belongs to H. Closure property. ये क्या है? Closure property. Because it is a subgroup, it satisfies closure property. A belongs to H, B belongs to H, A B belongs to H. So this is B. So this condition is satisfied. Now sufficient. Conversely, sufficient or conversely, sufficient condition. Sufficient condition means it is given. Means what is given? Given A belongs to H, B belongs to H, A B inverse belongs to H. This is given. Now we have to show that H is a subgroup, means H is a group. So what we have to show that? First we will show first closure property. A belongs to H, B belongs to H, A B belongs to H. Associative always exists in multiplication. And identity element exists, E belongs to H. And if A belongs to H means A inverse belongs to H. Inverse of an element also exists. Three things we will show here. And this condition is given. This is given, we will use this one. Okay. So by using this one, we will show three conditions. A belongs to H, B belongs to H, A B belongs to H. If A belongs to H, A inverse belongs to H, or E belongs to H. We will show three. And this is given. A belongs to H, B belongs to H, AB inverse belongs to H is given. So now suppose that A belongs to H or A belongs to H. We can say A belongs to H. We can write A belongs to H, A belongs to H also. Same thing, same as before. Now we will use here this property. Means B is A, B is equal to A belongs to. If AB inverse belongs to H, it means this element is belongs to H. It means H does not equal to 5. H is not empty. Means at least one element exists in H. At least one element exists. So we suppose that A belongs to H. One element A belongs to H. A belongs to H. A belongs to H. Now we come here. We will use this property. A belongs to H. A belongs to H. Means A inverse belongs to H. Means A inverse. It means what is A inverse? E belongs to H. So identity element exists in H. First thing. Now A belongs to H, B belongs to means this A belongs to H and also E belongs to H. We can consider B equal to E as a. So A belongs to H or E belongs to H. A belongs to H. First we suppose at least one element A belongs to H. Now E also belongs to H. Then E belongs to H. A belongs to H. We will apply this one. This is E. This is A. E A. E A means E A inverse belongs to H. Means E A inverse belongs to H by using this one. So E is identity. A is equal to A. So this is A inverse. So this is identity element exists. Here you can say identity element exists. Here inverse exists. So every element has its inverse in H. Now if A belongs to H means B belongs to H, A inverse belongs to H. So if A belongs to H, B belongs to H, A inverse also belongs to H. Means B inverse belongs to H means suppose B inverse belongs to H means B inverse. Means every element A belongs to H, A inverse belongs to H. B belongs to H and B inverse belongs to H. In H, every element has its inverse. If B belongs to H, then A inverse also belongs to H. Now A belongs to H. This is A belongs to H. B inverse belongs to H. B inverse belongs. Now apply this one. A belongs to H. B belongs to H. A B inverse belongs. Means A B inverse belongs to H. A B inverse. So what is A inverse inverse? Is A. A inverse inverse is A. It means A B belongs to H. So the A belongs to H, B belongs to H, A B belongs to H. It means closure property also holds. Closure. So suppose closure property holds, identity elements exist, every element has inverse, associated law exists in multiplication, then it means H is a group. H is itself a group. H is a group. It means and H is subset of G, then H is a subgroup of G. H is a group and H is subset of G. It means H is a subgroup of. So this is necessary and sufficient condition of a non-empty set. H is a group, subgroup of G. Is A belongs to H, B belongs to H, A B inverse belongs to H. If here if composition is addition, it becomes, if composition is plus addition, then we can write this theorem in the expression A belongs to H, B belongs to H, A minus B belongs to H. If composition is associative in addition, then this theorem changes in this form: A belongs to H, B belongs to H, A minus B belongs to H. Multiplication, it composition is not given, it is understood, it is multiplication. Okay. Then we will use A inverse belongs to H, B belongs to H, AB inverse belongs to H. If it is given, mentioned, okay, composition is addition, then we can say A belongs to H, B belongs to H, A minus B belongs to H is the necessary and sufficient condition of a non-empty subset. H is a subgroup of G. So this is very important theorems. Now, in next video, we will go some more theorems. There are the finite groups, theorems of finite groups, and all theorems are very important and interrelated also. We will use these theorems in some questions. We will solve. We have to show that this n plus or n dot is a subgroup of z dot like this. So we will use these theorems, or not subgroup. So these theorems are very